1, Relations and Functions. You are all in first prize today. I have a guest speaker. Say hi, Kenna.
Hi.
So, Kenna, the first thing we're going to talk about here is this graph a function? What do you think?
I think it is a function
And why do you think that?
because it passes the vertical line test.
Oh, that happens to be the next thing that comes up. The vertical line test. So, if you remember back to Algebra 1, the vertical line test says that if we take a vertical line and slide it through the graph, it cannot hit the graph more than once. If it does, then it's not a function. And we'll certainly talk about this a little bit more in class to refresh your memory. The other thing I want to point out before we move on is domain and range. Kenna, do you remember what domain represents, the x or the y values?
The x.
Good. So domain is a list of all the x values, and then what does it make the range?
The range is the y values.
Exactly. So range is a list of all the y values in a function. And we're going to really be getting into detail a lot more than you did in Algebra 1 in class. I'm just going to introduce you a little bit in this video. So when we look at this function right here, all we have, well, I shouldn't call it a function yet because we don't know if it's a function. But when we look at this relation, we have 4 ordered pairs, which are just points on a graph. So, Kenna, do you think this is a function?
No.
Why not?
It doesn't pass the vertical line test.
Oh, well, let's try it. You can make this noise too if you want. No, you don't want to. Okay. So right here is where it hits 2 points. And because of that, the x value repeats, and it is not a function. So we're going to go ahead and write that. So this is not a function. And the reason would be because it does not pass the vertical line test. So we can still get the domain though. Kenna, what do you think the domain is?
2, 3, 1.
Good. And we don't have to include the other 2 because it repeats. And so we don't have to name it twice. We're going to get into set notation in class, but for now, I'm just going to write it like this. Here's the domain, x equals 2, 3, and 1. Good job for not saying 2, Kenna. So then the range, we're just looking at the y values. Again, we don't have to repeat anything. We don't have to say it twice. So I'm just going to write out the y values in this range, and that would be 3, 4, and 7. And so just to remind you again, if we're determining whether or not it's a function, all you're doing is paying attention to the x values. And if anything repeats, it's not a function. So I'm going to have you go ahead and try example 2 in your notes. Remember, from now on, I'm collecting all of your notes for this video, so make sure you're writing everything down. Go ahead and try this example. Pause it if you need to. So now we get to special functions. I don't think you've seen a function like this before. This is called a step function. And the example that you see here is actually called the greatest integer function. And we'll get a little bit into class of what exactly this represents. But for now, I'm just going to look at the graph. And of course, Kenna's going to help me figure out what the domain is. Kenna, looking at this graph, what do you think the domain is?
I think the domain is all real numbers.
You would be correct. Nice job, Kenna. You really remember domain and range well. So that's right. It is all real numbers because I'm looking to see what x values are covered in the ordered pairs of this graph. So if you can picture ordered pairs being represented, the domain is all of the x values that would be included. And again, we're going to get into this a little bit more in class. So now I just want to kind of introduce it. So there's a symbol for x for all real numbers. Domain, we're talking about the x values. This symbol right here means an element of. And this symbol right here is all real numbers. So let me just write that out. The way you would say this is an element of. And then this is the symbol for all real numbers. Okay. And then when we look at the range is different. If you can see, I have spaces here. So it doesn't actually include all of the y values. It actually only falls on the integers. So the range is actually the set of integers. So the range is all integers. And like I said, we're going to get into set notation, but I'd rather talk about that in class. I just want to introduce it for now. So here's another example for domain and range, and this is a graph of an absolute value function. So we've discussed absolute value equations and inequalities. This is what the graph of one looks like. And so kind of when you're looking at this graph, what do you think the domain for this one is?
Well, I think this domain is also all real numbers.
And that would be correct. Good job, Kana. So I'm going to write it like this, and I'm going to go ahead and tell you what this means in class tomorrow. I'm going to read it, and then I'll write it out for you in class tomorrow and tell you what everything means. This is how you would read it. All values of x such that x is an element of all real numbers. So this is called set notation. And we'll get into it a little bit more in class. And I'll let you off the hook, Kana, and I'll do range. So for the range, we're talking about the y values. I'm also going to put this in set notation, which is, I'm going to use braces for that. Now we're talking about the y values, so this is going to be all values of y, such that, well, I don't have a graph down here. If I'm looking at the y-axis, the y values, the very lowest y value is right here, which is a y value of 0 if I go over to the y-axis. And then it goes up, and it keeps going up because there's arrows on the end. So the range is going to be all values of y such that y is greater than or equal to 0. Domain is one of those topics where you really have to practice in order to get it down. I'm going to give you one more example to try on your own. So that makes 2 examples for this that I'm especially going to be looking at when I collect your notes, but I am collecting all of your notes. So here's your last example. Try it on your own and have it ready for tomorrow. Kana, thank you so much for joining us today.
No problem.
Do you want to say bye to everybody?
Bye.